18,000 earthquakes since 2023. The strongest quake in 40 years. 5,000 tons of carbon dioxide rising through the crust every day. Beneath Naples, a supervolcano is awakening, and a new scientific model has done something no forecast has before. Put a deadline on it. Between 2030 and 2034, the caldera hits a critical threshold. 500,000 people live right above it. The ground hasn't stopped rising. On April 28, 2026, a new preprint appeared online, and with it, a new kind of warning. Davide Zaccagnino and Carlo Doglioni, both steeped in Italian earth science, had spent years sifting through the raw numbers, ground deformation, seismic strain, volcanic gas, looking for a pattern that could explain why Campi Flegrei's unrest kept accelerating. What they found wasn't a gentle curve, it was a mathematical cliff. The data didn't fit a simple exponential. Instead, it matched something sharper, a finite-time singularity, a point where the rate of change explodes toward infinity. In their model, the equation isn't just a line on a chart, it's a countdown. The critical threshold, T sub c, lands between 2030 and 2034. The numbers are stark. Since 2005, the caldera has risen about 1.4 meters. The model projects that by the early 2030s, total uplift could approach 4 meters, nearly triple the highest levels ever recorded in the modern era. This isn't a hypothetical. The regularized singularity equation, x of t, is approximately t sub c minus t raised to the minus beta power, fit the seismic, geodetic, and carbon dioxide flux records better than any other approach. The advantage wasn't subtle. The AIC scores, a measure of statistical fit, gave the power law model a clear edge. The preprint hit a nerve. Some called it alarmist. University administrators and senior officials at the INGV pressed the authors to avoid making deterministic claims about eruption dates. But the team didn't back down. They insisted the singularity isn't an eruption forecast, it's a mechanical threshold, a regime change. What happens at T sub c could be an explosive release, or it could be a new phase of Bradyseism. Either way, the clock is ticking, and for the first time, the risk isn't abstract. It's dated. But equations don't erupt. The next question is brutal in its simplicity. What does the ground say? Seismic alarms are no longer abstract. Since 2023, the ground beneath Naples has rattled with nearly 18,000 catalogued earthquakes, each one a data point, each one a reminder that Campi Flegrei is restless. The raw numbers alone are enough to rattle nerves. A magnitude 4.6 quake hit Pozzuoli on June 30th, 2025, toppling the ridge of Pinata and forcing schools to close across the region. Less than a year later, on May 21st, 2026, a magnitude 4.4 shock in the Gulf of Pozzuoli triggered a swarm, with 12 distinct events within hours, all at a depth of just 3 kilometers. Ferries stopped. Public buildings shut their doors. The shaking reached as far as central Naples. But that is only the surface story. A team at Stanford, led by Gregory Barroza, William Ellsworth, and Xing Tan, rewrote the seismic record using deep learning. Their AI pipeline scoured continuous waveforms from the INGV network, quadrupling the number of detected events. The official catalog had 9,000 quakes. The AI found more than 46,000. Hidden swarms came into focus. A ring-shaped fault, invisible to human analysts, traced itself around the caldera rim. Every uptick in shaking, every burst of microquakes, became a clue in a pattern that standard monitoring missed. The largest shocks are only the tip of the iceberg. Beneath them, the AI revealed dense clusters of tiny ruptures, foreshocks, aftershocks, and a persistent background hum. The swarm before the June 2025 quake, the sudden burst in May 2026, the background noise that never quite fades. All of it points to a system under strain, accelerating towards something the models call a finite-time singularity. But what exactly lies beneath the city? The answer, for now, is still hidden in the shaking. Campi Flegrei is not a single volcanic cone looming on the horizon. It is a buried giant, a caldera stretching nearly 12 by 15 kilometers, its rim lost beneath suburbs, rail lines, and the sprawl of modern Naples. 24 craters and vents are scattered across this bowl, some hidden under apartment blocks, others marked by steaming fields at Solfatara and Pisciarelli. The caldera's true scale dwarfs the city above it, yet the word supervolcano misleads more than it clarifies. The last truly colossal eruption, the Campanian ignimbrite, happened almost 39,000 years ago, unleashing 300 cubic kilometers of ash and pumice. Since then, the only magmatic eruption on record is Monte Nuovo in 1538, a brief, violent dome-building event that left a hill where farmland once stood. Most of the time, Campi Flegrei's power is silent, expressed in slow ground swelling, hissing gas, and the uneasy knowledge that hundreds of thousands live inside its fractured bowl. What forces move this sleeping structure, and how does the ground decide when to rise or to crack? Marble columns rise from the ruins of the Naples and Pozzuoli, their surfaces riddled with neat, round holes. These are not scars of war or weather, but the quiet work of marine mollusks, creatures that can only live underwater. 2,000 years ago, this Roman marketplace stood above bustling streets. Then the ground sank, the sea flooded in, and mollusks bored into the stone. Centuries later, the land lifted again, hauling the columns back into the open air, the mollusk borings now high above the tide. Each layer of damage and repair, each band of marine life, is a ledger entry in a cycle older than any living memory. Bradyseism, slow rising and falling of the earth, etched its timeline into stone, long before seismic graphs or satellite maps. The ancient city adapted, rebuilt, waited. But the pace was slow, measured in lifetimes. Today, the ground moves faster. The columns are silent, but the city above them is anything but. What happens when ancient cycles collide with modern speed? Pozzuoli lives on edge. 80,000 people move through their days with one eye on the ground, the other on their phones. Alerts come in bursts, sometimes a drill, sometimes the real thing. In May 2024, after a swarm of tremors, inspectors found cracks slicing through dozens of apartment blocks. 83 families got the order: leave now. Their bags were already packed. Shelters opened overnight in the Palatine Cone Zone. By September 2025, another 11 families on Via Napoli were told to evacuate after engineers flagged collapse risk. These aren't mass exoduses, just a slow, grinding attrition, family by family. School closures, ferry suspensions, emergency grab bags by the door. Municipal workers dredge the harbor, trying to keep the lifeline open. The city adapts, but fatigue grows. Each micro-evacuation chips away at the sense of normal. And beneath the streets, invisible hazards rise: gas, heat, and the silent pressure building through every crack. Carbon dioxide pours from the Solfatara and Pisciarelli vents, roughly 5,000 tons every day. That is more than 8 times the long-term average, enough to suffocate a basement in minutes. INGV's May 2025 bulletin flagged vent temperatures at 168 to 173 degrees Celsius, with deeper reservoirs estimated near 350. But the most unsettling discovery comes from below: a 3.5-kilometer-long crack, mapped by the GFZ-PISA collaboration, cuts through the caldera's brittle crust. It is a potential pathway, a weak seam, where gas and heat can surge upward unchecked. Stanford's team proposes a radical fix: lower the groundwater table, reduce pore pressure, and blunt the seismic feedback loop. Controlled pumping, barrier wells, a kind of engineered pressure release. Italian volcanologists push back. They warn the system is too complex, too magmatic, too volatile for simple plumbing. Dewatering could trigger subsidence, contaminate water, or even accelerate unrest. The debate is fierce. Tinker with the caldera or let it run its course? No one agrees on the answer. The next move could decide the fate of 500,000 people. Civil protection officials count heads, run drills, and sign agreements they hope they will never use. The numbers are staggering. 500,000 people in the red zone, more than 800,000 in the yellow. The government has earmarked 500 million euros for a package, on paper enough to fund rapid bus fleets, seismic retrofits, and a web of hosting agreements with towns far from the caldera. Every year, officials stage a 72-hour evacuation exercise, rehearsing what would happen if the alert jumps from yellow to red. The Bradycism risk tier, introduced in early 2026, lets authorities shut schools, reinforce buildings, or order partial closures without triggering panic. Industrial giants in Pozzuoli, including defense contractors, keep operations running under strict insurance clauses and contingency plans. The machinery of readiness is vast, but trust is brittle. Residents remember past evacuations that ended with nothing but lost wages and broken routine. When the next order comes, will anyone listen? 30,000 people were forced from their homes during the Brady seismic crisis from 1982 to 1984. Armed police moved block by block through Pozzuoli and the Red Zone, shepherding entire neighborhoods onto buses. The eruption never came. Instead, the ground settled, and families returned to find jobs lost, businesses shuttered, and trust in official warnings eroded. That memory lingers. Every new tremor, every evacuation order, revives the old skepticism. Will this be another false alarm? Today, the official alert sits at yellow. INGV issues daily bulletins, measured, technical, never dramatic. Their language is deliberate. Significant uplift, heightened seismicity, but no eruption imminent. Scientists insist on transparency, but avoid certainty. They walk a tightrope, balancing the risk of panic against the risk of complacency. Residents check their phones, scan for the next update, and remember the last time the city emptied for nothing. The question hangs in the air. When does caution become paralysis? The decision, stay or go, remains suspended, with no one willing to call the next move. Today, evacuation drills unfold under banners of reassurance. Meanwhile, the data curve bends toward a finite-time singularity, a point of no return, not just for the caldera, but for everyone above it. In Naples, denial and urgency now share the same uneasy ground. The clock is ticking.